Okay, so let's keep working on this question. We have triangle ABC, and we're trying to determine the number of possible triangles for each of the given measures, whatever. Okay, so side length A is 8, side length B is 10, and the measure of angle A is 20 degrees. So whenever you see the number of possible triangles or how many triangles, you're always going to use the law of sines. Now in the law of sines, you do sine of A over A is equal to the sine of B over B. So we're going to use that angle, okay? So let's do sine of 20 over 8 is equal to the sine of B over 10. Now this is actually good because you didn't get to see using the law of sines to solve for an angle before. So this is how we solve for an angle. It's the exact same thing. So I'm going to cross multiply again. 10 times the sine of 20 is equal to 8 times the sine of B. Now I want to get the sine of B by itself, so I'm going to divide by 8 on each side. And I'm going to type all of that into my calculator, and the answer it's going to give me is sine of B is equal to some decimal. So let's see. I'm going to type all this in. I have 10 times the sine of 20. Always make sure that you're in degrees instead of radians when you're doing this. Hit enter, and I'm dividing that by 8. So this decimal right here, 0.42, whatever, that's sine of B, but I want to know what angle B is. So angle B, you do second sine, second answer, hit enter, and angle B is 25 degrees-ish. We can round. 25 degrees. Alright. This is the reason why we are using the law of sines. Let's just think about this for 1 second. Because I know that you've done this before in other chapters. So when you get to the end of a question and you say sine of B is equal to a positive number, I always had you saying that means that there's 2 different answers. And there are 2 different answers. All students take calculus. Sine is positive in the first quadrant and in the second quadrant. And that's exactly why we're using the law of sines. Because say we used law of cosines, that means it'd be positive in the first quadrant and the fourth quadrant. But let's think about what we're talking about here. In the fourth quadrant, those are angles that are really big. That's like 300-degree angles. And if we're talking about angles of a triangle, it'd be impossible for this to be 300 degrees because we're just talking about angles of a triangle, and they have to, add up to be 180 degrees. So that's why we use the law of sines, because if I'm talking about law of sines, then one of my answers is going to be between 0 and 90. The other answer is going to be between 90 and 180. So in those quadrants, it's possible for us to find angles of a triangle. So that means that I have 2 different answers. Let me write this out so I have a little bit more space. Measure of angle B has 2 answers. Same thing as what you've done before, 25 degrees, and in the second quadrant, 180 minus 25, which is 155. Whoops. Yep, 155. Okay. The reason why the question says how many numbers of triangles are possible is because I'm not exactly sure that both of those angles are going to work. We just got 2 possible angle measures of what angle B could be, but I'm not sure if either of them work. So if I put a 25 in right here, I think that that will be okay within, this setup of this triangle, because that angle's 25, that angle's 20. So if I add those together, it's 45, meaning that I have 135 degrees left over for this angle. Does that make sense? So 25, yep, that'll work. It'll work within the confines of that triangle. Okay, now let me erase this. Well, that was one of my options. I also have another option. I have the other option of maybe angle B is 155 degrees. Does that work? If that angle is 155 and the other one is 20, that adds up to 175, meaning that we only have 5 degrees left over for that angle. That means that that angle is really, really big and that angle is really, really small, but it still mathematically works. You know, we're allowed to have a really big angle and a really small angle. So yes, that triangle works as well. So how many triangles are possible within this question? We have 2 triangles. That is my final answer, 2 triangles. Okay? Let's do another question. Hopefully it won't be as confusing the second time around. Okay, so now we're going to do it using new numbers. So triangle DEF. Remember, this is called the ambiguous case because I'm not sure how many triangles are possible. This is why your teacher didn't let you use angle side side, because apparently if you have a side length of 8, a side length of 10, and an angle of 20, then there are 2 triangles that you could make out of those numbers. So that's why you weren't allowed to use this. Okay, so DE is 24. EF is 18. And the measure of angle D is 15. I'm going to use the law of sines. Now I have the sine of angle of 15 over 18 divided by, now I have to use this angle because that's the side that I have. So the sine of angle 15 over 18 is equal to the sine of angle F over 24. Okay, we're going to cross multiply again. 24 times the sine of 15 is equal to 18 times the sine of f. And I want to get the sine of f all by itself. So I'm going to divide both sides by 18 and then put all that into my calculator. So the sine of f is equal to all of this stuff because that's gone. So 24 times the sine of 15, hit enter, divide that by 18. So sine of f is equal to 0.345. So yet again, you see that this is a positive value. So sine is going to be positive in the first and the second quadrant. So I'm going to have 2 different answers. One here and one here. So f is equal to, let's see, second sine, second answer. Whoops. I do not know what just happened. Go away. Alright, second sine, second answer. Hit enter. Alright, so f is 20 degrees. We can round in these questions, so it's okay. Round it to the nearest degree. 20 degrees, or 180 minus 20 is 160 degrees. Okay? Those are my 2 possible answers. So I'm going to go through them and I'm going to check to see if both of these angles work in my triangle. And if they both work, then I have 2 possible triangles. If only one of them works, then I have 1 triangle. So let's see what happens. Let's see if 20 degrees works. If I put 20 degrees right here, that one's going to work because then I only have 20 and I have 15. That adds up to 35. Meaning that I have, I think, 145 angles left over for the third one. Oh, wait, I did that backwards. Sorry. We were solving for angle F. Not that it matters, but this is angle F, so this would be 20. And this would be 145. So that completely, absolutely would work. That one would work, so check that off. Now let's erase these. Let's try the next one. If this was 160 degrees, 160 plus 15, that gives me 175. That means I'm going to have 5 degrees left over for the third angle. It's really small, but yep, it works. So I have 2 triangles that are possible. See, it's not that bad. I think that we have 2 more questions left, and then that is it for this section. Okay? So let's see. Oops. This time I have triangle PQR. And PQ is equal to 12. PR is equal to 15. The measure of angle R is 100. Okay, so if I'm doing law of sines, the sine of this angle divided by that side is equal to the sine of this angle because it's across from that side. So you got to figure out which angle you're using. So let's see. Sine of 100 divided by 12 is equal to the sine of Q divided by 15. So you can write it out if you want, but I know that if I'm going to cross multiply, I'm multiplying that times that, and then I'm going to divide by 12. So if you want to keep writing it out, that's fine. It's just kind of hard for me to write it out every single time. So I'm going to do 15 times the sine of 100, enter. And then because I do 12 times the sine of Q, I'd have to divide by 12 to get sine of Q by itself. So divide by 12. Sine of Q is equal to 1.23. Hopefully you should stop at this point and say, hey, that's not possible because sine can't be bigger than 1. But if you did forget, you could always just put in your calculator and it's going to come up with an error. So Q does not exist. So because that angle does not exist, how many triangles are possible? 0 triangles are possible in this question. Alright, and one more question really quick. So we have triangle ABC. B is 9, C is 12. Measure of angle C is 45. So I'm going to do sine of 45 over 12 is equal to, and it's going to have to be the sine of B over 9. Cross multiply those. So 9 times the sine of 45, hit enter, divide by 12. That's what sine of B is equal to, but I want to know what angle B is equal to. So second sine, second answer. B is equal to 32 degrees and also 180 minus 32. Whoops. And I'm going to stop and then just start this up in one more second.